Okay, we've just finished the density lab, and it occurred to me that we needed to be sure that we understood how to do adding and subtracting of sig figs differently from multiplying and dividing of sig figs. So let's start out. Best way is with an example. Let's do 24.0, and let's add to that 3.15663. Okay, now the way you start out is just like you always do. Okay, you know that you're going to add this up. So we have 3, 6, 6, 5, 1, point, and then a 7 and a 2. Okay, to here, nothing is new, I hope. Okay, we just got to line our columns up properly. All right, now what we do is we look and see the very first column that is going to have numbers on all lines. Do we have any treasure in there? No. Oh, that's nice. Okay, so I'm going to check this line against this line. Now, as I go up from here, do I see numbers on both lines? No. As I go up from here, do I see numbers on both lines? Okay, do I see numbers on both lines? Up here? No. Up on the top? No. Do I see numbers there?
Yeah.
No. Okay, the 5 isn't there. So, do I see numbers here?
Yes.
Yeah. All right, that is where you come back and you draw the line. Now, this is your number, to the proper number of sig figs. See how it works? Questions?
You don't round it?
Oh, yes, you'd round. I apologize. Thank you very much. You would round. So you go to the next door neighbor, right, and do your normal rounding. You don't go to here. You don't go to this guy. You don't go to this guy. You go to this guy right here, and because this is a 5, you would round up, and that would be 27.2, and that is your number.
Wait, Mr. Henry, so Mr. Waiter, so for this would be an example of rounding to the third significant figure.
This is rounding. You've got to stop thinking of how many sig figs. You're rounding by columns. It's different than multiply and divide. Very different. Are we okay?
Yeah.
Okay. All right. So basically what this says is that this number is limiting our accuracy of this number. This is a great, accurate number, but we're adding it to this, so, you know, this is fairy tale. Everything out here, all this stuff is fairy tale stuff because it's not going to improve our accuracy in our final answer. So we really only have 3 sig figs here that are worth anything. Okay, and that last number, just like on all sig figs, is a guesstimate. All right, now let's look at subtraction. Subtraction is going to be done in exactly the same manner. Let's do, let's get our pen back. Let's do 6.335, and we're going to subtract 0.26. Okay, as you would imagine, when I subtract out here, I'm going to get 5 and 7 and 0 and 6. Nothing is different than any other normal adding and subtracting. This becomes my starting point to figure out my sig figs now. Okay? Do I see a number in both rows? No. Okay, so I have to go to the next one. Now do I see a number in both rows? I do. So what we do is we draw the line. And now that we've drawn the line, we go ahead and look and see if we have to round. Okay? And because of the 5 right here, I'm going to have to round. So I get 6.08, and that's my final number. That's how many sig figs I can get with that particular operation. Because I had 4 sig figs here on this line. I'm sorry, 2 sig figs. Did I say 4? I meant 2. And here we have 4 sig figs. But that is irrelevant. All that matters is the columns. Are we ready to test ourselves? See how we're doing on it? See if we got it right? Now, here's your question. I'd like you to do the addition and figure out what the actual number of sig figs will be and the final number. So I'd like you to input the final number on your responder once you feel like you've got a good answer. Okay, what I'm looking for here is for you to put in the correct final number with its correct number of sig figs. We're not going to put in a number of how many sig figs. You're just going to show me the number with its correct sig figs by your answer as you input it. Okay, as you can see, we did a little bit better now that we understood what the question was. And let's see if the majority, the 77%, really have it. So I'm going to add the 2 to the 0, 2 to the 0, 9 to the 0, 5 and 6 are 11, and 9 and point and 1 4. Okay, does everybody, we all agreed to this point?
Yeah.
Okay, great. Now, let's look at it again. Do I have numbers in both rows? I do not, so I go on. Do I have numbers in both rows again? No, okay. And now do I have numbers in both rows?
No.
No, okay. Do I have numbers in both rows now?
Yeah.
Okay, that's where we're going to draw the line. The more accurately you space your stuff and whatnot, you can get a little better idea. I would like to have been a little bit more careful on this one. Anyway, that's where we are. Here's the number that we have to deal with. Now, do we have to do any rounding because of this guy?
Yes.
Yes, we do. So that's 14.92, and this should be our final number. And look at that, 77% of you. That's excellent. Now, those of you in the Rainbow Coalition, anybody have a question as to why you missed? Yes. Thank you for being brave.
So when it says 10, since the 1 doesn't have another number, you still count it?
I'm sorry, I didn't understand the question.
It says 4 on the top and it says 10. Since the 1 doesn't have another
4 and 10. Yeah. Okay. Oh, no, not to the, oh, I understand your question. You were saying there's no digit here.
Yeah.
Yeah, that doesn't matter. We're only worried about the columns on the right side, because the right side is where we get our accuracy for that particular level of measurement. Okay, because there's no number here, that doesn't affect what comes down. Very good question. Thank you for asking that. Everybody understand what she was asking?
Yeah.
Yeah, okay, cool. All right. You want to try one more of the pluses?
Yes, please.
Okay, let's do it. We had another question, and that was, if this 9 right here, oh, my goodness. There we go, put it back, yes. Now, this 9 right here is going to round that, oh, you little stinker, I don't want you to do that. Why are you doing that? Oh, because I'm on a pointer. All right. So this guy right here, what happens is that's going to round the 1 next door up to a 2. Now, that's where the rounding ends. You always start at the line, and you just round with the first number to the right of the line in this row right here. Okay, and that takes care of that guy. Okay, here's our numbers that we're going to add up. I'd like you to go ahead and add those up and then round them to the correct number of sig figs.
New question.
Yes, okay, we got to start a new question. I'll take care of that right now. Okay, it looks like we're in fairly good shape on the answer here. Let's see if the majority of 81%. It's higher than last time. Last time it was what percent? 77. A little bit higher. Okay. Let's go ahead and add up. We get 2, 2, 8, 2.8, 9, and 7, and 3. Okay, so we look at the two rows, and no numbers here. Do I have numbers in both?
No.
Do I have numbers in both here? No. Do I have numbers in both here?
Yeah.
Okay, we're good to go. That's where we draw our line. All right, and now we're going to look for this guy right here, and he's bigger than 5, so we're going to round up, right? 3, 7, 9, 8, and 0.3, and that's our final answer. And by golly, 70% of you got it. Okay, the 8.2. This gang is in really good shape too. You just didn't do it. Your only problem is you're not rounding properly. Okay, and I don't know what this group here did, but at any rate, you guys here are doing just fine. Just be sure that you always do the rounding, and you're rounding to the right of this line right here. Okay, that's where you're going to round from, and it's always from that point. Okay, here's our next problem. This is subtraction, and subtraction works exactly the same way as addition. I'm not going to explain this part. I want to see if you can bring it into what we just did and figure out what's happening. So I'm going to have to subtract here. This would be a 7 and 2, because I'm acting as if those are zeros. And this would be 9, 8. And this guy, because I borrowed from the 4 to get the other numbers over there, is a 1, and a 1, and a 3, and a 6, and a 2. I'm sorry? Did I do something wrong?
Is this a question we're going to put up on the responder or what? You didn't give us a chance to answer it.
I didn't give you a chance to answer it. So go ahead and finish. That's great. All right, we got 81% of the class doing pretty well on this. This is our first time through on, I'm just going to skip to right here. Is everybody okay why I draw the line where it is?
Yeah.
All right, cool, because there's no number here, here, or here. So that means we just had to do our normal subtraction like we're doing the normal division, or normal addition. And now we're going to look to here, and we're going to round up. So we have 26.312 is our final answer. And yeah, most of you have the idea here. Back in this area, are we very far off? Are we getting at least to the right number of sig figs? Anybody did not? Well, I won't let you. I won't make you identify yourselves. But I hope you're getting the idea again of what's happening with addition and subtraction. Both handling it the same way. It has nothing to do with the original number of sig figs. It has everything to do with the column. The column is the only thing that is going to make a difference on these kind of problems. Okay, now we're going to switch over, and we're going to have a chance to do sig figs where we multiply and divide. Here, what you're starting with in the two multiplicans, is that right? Multiplicans? Whatever. The two guys you're multiplying together, that's going to make the difference in your final number. So let's multiply 21.3 times 1.666. Okay, would someone run that number on a calculator?
That's the same rules apply.
No, the rules are radically different.
Now it is 35.
Radically different. So when we multiply on our calculators, that's what shows up in the little window where it shows your answer. So we have our answer there. Now how many sig figs do we have? And here's how we figure that out. This is how many sig figs? 3. This is how many sig figs? 4. What's the smallest number of sig figs? 3. 3 is the winner. 3 is the winner because he's the least accurate. 3 sig figs, that is. This line right here. So I am going to go 1, 2, 3, and I'm going to draw the line.
We can't do the dropping like we do in the other ones.
Oh, no, absolutely not. Nope, nope. Because this number right here is accurate to three significant figures. This guy right here is accurate to 4 significant figures. So when they were measured, that's how it works. Now when they get multiplied, that's a whole different issue, you see, than adding and subtracting. Since this was very accurate and this is less accurate, the less accurate one, this guy right here, is the one that's going to limit how good an accuracy we can get in our final number, yes. Yes, we still have to round. In this case, we wound up with a number that was larger than 5 again, and so when we round this, it's going to be 35.5. And that is our final number. Any other questions? Okay, you ready to try one on your own? Okay, let's give it a shot. Okay, here's your new problem. Go ahead and multiply that little dude out, and let's see what we get in our final number at the end. I want the final number, okay? I want a final number. I don't want how many sig figs. I want a final number with the right number of sig figs. And by the way, just for fun, and we'll figure this out later, if this is mils, and this is also mils, I'm going to ask you at the end what the unit of measure is when we're done. Okay, when we run this number on our calculator, this is what shows up, the red number there. And so we're going to do a couple of things here. Let's figure out who's got the right thing in mind and who's having problems still. Okay, how many sig figs here? 3. Okay, how many sig figs here?
6.
Yes, 6. Okay, so who's the winner? 3. Okay, so I'm going to go 1, 2, 3, draw the line. All right. And now I see that this guy is bigger than 5 again. I wish we would have one come out so that it's less than 5, because you don't always round up. Don't get the idea you always round up. It's only because this number is 5 or larger. So because the 7 is 5 or larger, we're going to make this 233, and that is our final number, and the 31 percenters have it. Okay. Now, the number that we have at 232.75, I don't know how you came up with 5 sig figs.
Oh, I was thinking addition.
You're thinking addition. Yeah, I probably should write these a little bit different. Would this make it better for you if I wrote it this way? 38.6628.
No, actually it wouldn't matter.
It wouldn't matter. You can still control. Okay. All right. But are you getting the difference now between the multiply and the divide, or multiply and the add and subtract thing? Okay. It's all dependent upon the sig figs of the 2 numbers involved, and you go with the guy that has the smallest number. Okay. This time I'm going to write the numbers a little bit differently. I'm going to write the 35.1 times 2. Okay? Let's get the right number of sig figs at the end. All right, here we go. What is the number coming out of a calculator?
70.2.
70.2. Is that the number? Is that the number? Okay. Now, how many sig figs do we have here? 1. How many sig figs here? 3. Okay, so 1 is the winner. So here's where we draw the line. All right? This is going to be fun. All right, so this number doesn't round that up, does it?
Nope.
But it still has to be, it can't be 7. Because 7 would mean that that the decimal was between the 3 and the 5. And it would be 7. The magnitude of the number is wrong. Okay? just forget about the 0.1 for right now. 2 times 35, 70. Okay? 2 times 35 is 70. If I wrote 7, you would question my sanity, wouldn't you?
Oh, I get it.
Okay? Yeah, right. Yeah, you're understanding now. Good. So the 7 here that we see on the largest proportion of the class, your thinking is not that bad. You rounded to the right place. But I'm glad I did this particular problem because it points out the fact that I still have to have a 2-digit number. Now, 70. How many sig figs?
1.
1.
Good trick.
So that's how I got the magnitude, you see? So this guy, because there's no decimal, the 70 with no decimal is 1 sig fig. Now how many sig figs, folks? Getting that? See, this makes a difference, doesn't it? Another way you could have written that would be like this. 7 times 10 to the 1. Now it's in scientific notation. Scientific notation is any number times a power of 10. 10 to some power. Okay? So the 27 percenters in this case have it. All right? Want to try another one?
Yeah.
Okay, here's our new problem, and we're going to see if we can figure out what happens with this guy, and what we're going to progress and start. Yeah, okay. So what we want to do is do the multiplication, get the number down from your calculator, and figure out how many sig figs you need to have in your answer. There we go. What is the number off the calculator?
49.662.
49.662 from the calculator. Okay, how many sig figs here? 2. Sig figs here? How many sig figs here? 3. Okay. Who wins? The 2. Good. Okay, so we're going to draw the line right there. And again, we get a number here that's bigger than 5. Got to get a number that's smaller than 5. Anyway, so we're going to go ahead and round up. And for our final answer, we have 50. Now, how many sig figs are we supposed to have? So what do we? How do we make it? 2 sig figs. Put a decimal in there. Absolutely. So the 50 point is the winner.
It was me.
Yeah, was that you? It was more than one of you. It's more than one of you. Okay.
So if you don't put the decimal, it's wrong.
If you don't put the decimal, how many sig figs does it have?
So it's wrong.
That's right. That's right. You have the right number, but your sig figs are off. Okay? You got the right quantity. Everything's good except the sig figs are wrong. That's all. Okay? So that's how sig figs work in multiple. Okay, there's your number. Divide it out on your calculator. Write down the whole mess, and then you want to get the correct number of sig figs. Yeah. Okay. Let's look now at what our number has to be. The calculator is going to tell us what number. 5 what?
Let's say 5. It comes out straight up 5.
Ooh, 5. Okay. So, if we come up with a 5.5 and nothing else, that is how many sig figs? Okay. How many sig figs here? 4. How many here? 2. And how do we make that a 2-digit or 2 sig fig number? 0.0. Now you see that would be different than making it 50, wouldn't it? Because that would be it has 2 problems. If we write 50, the sig figs are wrong because you have how many here? 1 sig fig, because that 0 doesn't count because there's no decimal in the number. Okay, so here we have not only the wrong number of sig figs, but we have the wrong magnitude. We started out with 25 and we divided by 5. How in the world could it be 50? It's supposed to be smaller, isn't it? Yes.
It is 5.0.
It is 5.0. That's what I wrote here. Yeah. So what I was doing is I was using this as an example of something that was wrong. Okay. So good question. I'm glad for all the people that are watching this on the video right now. Okay, I'm putting this up on YouTube. I'll put the link on tonight's homework page, so you can pick it up again if you want to. Okay. I wanted to go back and point out what happens. I wanted to point out what happens when we have multiply with units of measure. If this guy is mils and this guy is mils, it multiplies. And mils times mils is what? Mils squared. Okay, or you could say, no, you couldn't. Mils squared. Yes.
If one is like liters and loves milliliters, you have to convert it to the same thing.
Yes. You can't multiply mils times liters. Okay, mils has to be converted to liters, or liters has to be converted to mils first.
You only multiply the mils if it's multiplication, right? Because you're doing it off the subtraction.
Well, oh, I'm sorry. I meant this to be a multiply problem. Let's good. Let's get that fixed, and let's go to a multiply problem and apply that there. So here in this one, that would be a multiply problem, and if this guy were mils and this guy were mils, then we would have mils squared in our answer, and this guy would be ml squared.
That's it for multiplying or dividing?
Multiply. Oh.
That's the
Oh, you're sharp today. Actually, I was just testing you.
Yeah.
Nah, no, I just messed up. Okay, so in the divide, what would that be? There'd be no unit of measure. Because mils divided by mils is 1. ml by ml, 1. Yeah, okay. If this were multiply instead of divide, then it would be the mils squared that I said originally. I was thinking I was doing a multiply problem, and I thought wrong. So we got that fixed up for you.